Welcome to the session on testing, on how we tested Airflow 3 for stability and reliability. Uh, I'll give a brief introduction about myself. I'm Phani Kumar. I'm an Airflow committer since 2022. I'm a senior manager in Astronomer, managing the open source team.
Hey everyone, good evening. I'm also an Airflow committer and I work at Astronomer.
Okay, so during the course of this session, we will briefly discuss about the timelines that went into planning for Airflow 3 testing. We will also discuss about what we tested in Airflow 3 and how we tested it, basically the entire process. So let's start by briefly discussing why we need a test plan. So essentially in the software development lifecycle, planning for testing is as important as planning for development because even though both are interdependent, the aim is to deliver a high quality software, right? And testing has its own scope, objectives, and resources needed. While development focuses on building functionality like features, APIs, and integrations, testing focuses on verifying and validating that those deliverables actually work as intended. So without separate planning, testing tends usually to become an afterthought, and which leads to rust and incomplete validation of the functionality. So a dedicated test plan also helps us to uncover gaps or ambiguities in requirements. So with that said, we started planning for Airflow 3 testing during December 24, which went on till January of 25. And then once the test plans were ready after getting validation from the dev team, we started testing out alpha during January to February. And then we started testing beta. And post which we tested release candidates, which led to testing being completed. And why Airflow 3 was different when it comes to testing? Because primarily we did an architecture overhaul through the Task SDK framework. And we had multiple AIPs being delivered in Airflow 3. Like 12 plus major AIPs were done. And the entire UI was sort of redesigned and we migrated to React-based framework. So what was the impact after planning for Airflow 3 testing? So we eventually found literally 271 bugs overall. During the alpha build stage, we had literally 40 bugs being discovered. So essentially, alpha builds are for suppressing integration issues early before users ever see them. Usually, the stability of an alpha build will be low compared to a beta or an RC build. And it's supposed to be used by developers, contributors, and early adopters. So during the beta phase, we uncovered nearly 129 bugs, and beta builds usually expose the software to real-world use cases. And the audience is primarily advanced users and community testers, with which we gathered feedback and improved the tests. So post which we had the RC phase, we uncovered literally 102 bugs as part of the RC phase. And that was primarily the final validation near production conditions, and the stability is supposed to be high there, and audience is usually QA teams, maintainers, and power users. So
okay, so as we said in the last slide, 271 bugs we found during Airflow 3 testing, and those are a lot of bugs. How we got to them, let's discuss around that. So as Phani mentioned that with Airflow 3, we have, it's not only the version change, it's like we have complete re-architecture of Airflow throughout, from the back end, from the front end, everything was rewritten. So this needs a proper planning, and we wanted to keep our bases clean, right? So when we started planning for this, we wanted to ensure that we follow the basics of testing, and there it's come, which is test pyramid. So we ensure that we thoroughly go by that. Let's talk about that. So most of you might know about test pyramid, what it does, and why it is needful. Basically, with test pyramid, we try to segregate test in different levels. We can have multiple tests, but having it at different levels is something which helps us scale better. We wanted to ensure that we keep most of our tests on the unit level, Why on unit level? Because these are very low cost tests. It takes very less amount of time to run, and it covers our basics, right? And as you know, in Airflow OSS, for every PR, we mostly have unit tests which are being covered by that. So every PR was covered by unit test, which helped us throughout. Also finding the bugs, right? Then talking about integration test. So we have 12 plus AIPs which we had, and also for the previous feature, we ensure that we do have sufficient integration tests which are covering between multiple features, and it gives us enough coverage around, if let's say if something has changed in one feature, it's working fine in that, but it might regress other feature. So these integration tests helped us ensure that one feature is not regressing the other. End-to-end testing, we wanted to ensure that whatever features we are developing are being tested thoroughly. We create multiple test plans for new AIPs. We ensure that whatever use cases we have for Airflow 2 are running as it is, right? And on the top of it, you see that we did a lot of manual exploratory testing, right? Why it is needed? In today's generation, everybody is going through automation, right? But I feel like significance of manual cannot be over. Automation is just an aid to us. It gives us more ammunition. And in our process, we ensure that we used automation for regression, right? So regression helped us in ensuring that we are not regressing any other thing. So this is our testing philosophy, which we worked upon. Now, talking about our approach. So basically, we had 5 pillar approach in which we had task SDK architecture testing, which was the major backbone of Airflow 3. As you know that with task SDK now, worker cannot directly connect with the MetaDB, right? We have API server. So we wanted to ensure that we are doing the things right there. We had automated regression testing for ensuring whatever was working earlier with Airflow 2 is working as it is. We ensured that the new UI is validated thoroughly. There were thousands of screens, different workflows throughout. We validated everything. Obviously, there were a few bugs here and there, right? Even there would be some now, but we ensured that the critical workflows are covered thoroughly. Migration testing is something which is very, very important because we want, one of the goal for Airflow 3 was adoption. We want people to migrate to Airflow 2 to 3, right? Not only new user who are coming to Airflow 3, but users who has humongous amount of data, who have different workflows, multiple deployments, they are able to seamlessly migrate to Airflow 3. So we ensure that we do a thorough migration testing, and we did that. Also, for the new feature, as I mentioned earlier, we had to do a comprehensive validation throughout. Now, talking about testing test SDK. So basically, if you see from the user point of view, testing task SDK means we just need to ensure that whatever was working before is working now. We have just changed the architecture. We do not want user to like, technically there is a change, but whatever it was working for them earlier should work now as it is. So we ensured that let's say you have a DAG, right, and you're using previous import without the SDK. Those imports are working as it is. New imports with the SDK is also working. So we ensure that whatever regression DAG we were running with Airflow 2, we tried, executed with Airflow 3 and ensure that those work fine. So compatibility is something which we give more focus on. And from the positive side, as one of the goal for SDK was that user code cannot touch the DB. So we did some positive testing around that. We tried connecting MetaDB from a worker from the DAC code and tried different ways and ensure that it is not possible because it's related to security. Now, talking about the daily automated regression testing. So I don't have the count, but I can clearly remember that there was so many changes during the Airflow 3 development. At least 10 PRs were getting merged every day, right? And to test these kinds of changes throughout is can be nightmare. And that's where we ensured that we have an automated way so that whenever there is a new issue or new regression through any of the PR, we are alerted. So one way we were getting our unit tests were catching them, and this was our other gating, right, which helped us. So what we did was In Astronomer, we have our nightly builds, which are nothing but just a clone of main, right? So every day we create a runtime nightly deployments, which are nothing but Airflow OSS main for every day. So essentially, we were getting new changes with every build. We had an automated way in which we have a lot of regression tags, which are categorized by different tags, and these different tags are nothing but features. For example, tags for let's say tear down, setup tear down data sets, right? Tags for deferable. So we have all the features covered, and these tags were being executed in our deployment with the help of Airflow APIs, right? We trigger them, and as you know that we have also made so much change. We have like completely revamped our APIs, right, using Fast API. So we created a collection using Newman, right, and we were triggering that collection using Newman CLI, right. That was also ensuring whatever the backend changes in the APIs are also being catered. So after triggering our DAGs and REST APIs, we collect the results. We share the results in our with the help of notification on Slack and other mediums. And if there are any failures in our regression DAG or APIs, we were alerted and we were just raising issues in OSS and trying to get it rectified. So how it helped is it helped us catch bugs early in the cycle. Why it is important? Because we don't want to have multiple RCs, betas, alphas. We wanted to get the issues right there, right then, and get them sorted. So that's how this automation regression testing helped us.
Yeah, let's have a quick discussion about the UI testing. Since UI there was a total overhaul of UI in Airflow 3. We tested majority of things through manual testing. We tested majority of critical workflows like XCOM related, diagram related, and connection screens. Yeah, we also performed thorough migration testing as well. So as part of this, couple of the commands that we used were Airflow DB migrate, which enables us to test the migrations. And we also tested the configuration aspect here, where we used Airflow config lint command. So this command is primarily for ensuring that the configuration changes work when users do a migration from Airflow 2.x to 3. It primarily checks for issues in your airflow.config and whether it is ready for the new release. And we also utilized Airflow config update command, which uses, for example, whether updates are needed and whether your configuration is up to date. And in case if any issues were found during Airflow config update, we use a -fix flag to ensure that we automatically apply the configuration changes instead of performing a dry run here. Along with this, in case the users need to update their DAG code, we configured rough rules, which enabled us to ensure that the user's DAG code is also compliant to the Airflow 3 release. And how we tested migration. So we uncovered a couple of serialization issues during the testing, which was promptly fixed by the community. And another principle is we also needed to check whether there are any issues in rendering old data, because the deployment, whatever data is there in the Airflow metadata database, we should ensure that it gets rendered on the new UI as well. So as part of which we ensure that there are no serialization issues, there are no issues with rendering the existing data present in the metadata database.
Okay, so now talking about the AIP validation. So we had, as we mentioned, we have total of 12 plus of AIPs with Airflow 3 development, right? Starting from DAG versioning and bundles, data sets and asset-centric syntax, scheduler managed backfills, complete revamp of UI with AIP 38, and REST API, AIP 84 and AIP 83. So to do that, we had to test thoroughly with this, right? And what we did was we created manual test plan initially, right? And we followed that with every change in new release of alpha, beta, and RC. We executed these tests initially manually, and we are now automating them right now as we speak. Most of them are done as well. So having positive negative test cases around that and covering and getting reviewed them by community really helped us. We ensured so, and also we asked community that they can help us test that. So basically, what we did was we had the AIP docs. We covered what all test cases, positive, negative edge, we would be running around, and we used the same set of test cases which can be run. And it's not only that only one person executed it; multiple persons executed, ensured, reviewed, and we had a backlog what we need to verify along, and we had a plan around that during that. So talking about now testing infrastructure, so I would say there are multiple infrastructures which we used here. Uh, Most of you are aware of Breeze. So Breeze was really help during the testing throughout. It took us like maybe a minute to start up the environment to check any changes. If there is a new pull requests which are being merged, we were able to test it thoroughly with Breeze. So it helped us a lot. This utility. Then what I discussed around the nightly integration build. So we had Astronomer infrastructure in which we run our different nightly deployments with different executor, let it be salary and Kubernetes. So which helped us catch issues early. Unit testing with the Airflow CLI. We were constantly adding more things in CI, which was helping us catch these issues. And not the least, we were also testing the system test, right, in which we have pipelines from AWS, Google, and Astronomer, which we were running, and they were helping us find issues in the providers as well if there are any. So these are the different infrastructure we used to test Airflow 3. Now, I would like to talk about community collaboration here. So the kind of changes which we had, I'm pretty sure the stage we are in, it could not be possible if we don't have the community collaboration. And I would like to give a shout out to our dev calls, which we had regularly start from December 2024. So these calls give us a platform to discuss throughout community, and not only from testing. I am saying that from development point of view. So we have bi-weekly calls on this, in which initially we started getting to know, right, what are the different AIPs which we would be working on. And for me, right, as I was working on the testing end here, it bring me in early in the cycle. So I was aware of what are the changes and going, right? So basically we were doing static testing right from the start, right? It helped global, it included global participation. We shared our knowledge, the test case which I was talk about, we shared, get it reviewed in these dev calls, right? We have we have created a test plan in which we have confidence level of each of these AIPs, regression, whatever, in terms of migration, and we were getting that reviewed. So these, what it helped is in faster issue resolution. We didn't have to wait on an email or in a Slack. We were just getting our query resolved over the dev call. We had a set agenda for every week, how we would be resolving this issue. We had the timelines, right? And we had a better test coverage. So I want to really, without these dev calls, I think we would not be in state as what we are today. Now talking about the key learnings, I feel like I would like to say that the approach we took, right, the testing pyramid, it works. Why it works? Because we had a combination of all three. We were covering all the levels: unit testing, integration, manual, end to end, right? We ensured that whatever are the major architectural changes are being validated. We ensured, as we discussed earlier, that migration testing, let it be on, it's not only we tested on Postgres, we tested on MySQL as well, and tried SQLite as well, but there could be some issues there, here and there, you all know. So, but yeah, our major concern were Postgres and MySQL, community collaboration, and now the next goal is how we can improve better. So, next steps. So, we talked about that manual testing cannot go away, but we can just say that we don't have so much of people to work around and doing manual stuff. So now comes the next step. Whatever we did manually, we need to automate that as well. So in that, there are three things which community is already doing. There is already an Airflow E2E testing framework which has been created by Pavan. So with that, now a release manager, before even after cutting the RC, they can just run this in the Airflow CI, and they would be able to get to know whether there is any issues. So what we are doing here is, so we have an example tags which can be executed. So release manager doesn't have to wait, right? The next goal on this is that we would be creating an increasing coverage on this. The second thing is Task SDK integration testing framework, which Amog is taking lead on, and he has already contributed initial changes in it. In this, what we are doing is we are ensuring that whatever task SDK changes we are doing, we are also validating. So we found some issues due to the integration testing, and this particular framework would be helping us. The third thing is, as Phani mentioned, that mostly UI was done manually, right? And as you know that how difficult it is to test with every release same page, and there are so many scenarios. So we want to ensure that we improve this UI test coverage through automation. So we have started a discussion on dev call, and maybe I would be concluding that thread very soon. So we are planning to add some unit and some system level test on UI test coverage. And for system test, we are thinking to use Playwright with TypeScript. So that is what we would be working on. So yeah, I think that's are the next step for our journey for our next releases from testing point of view.